This video is going to be about solving two-step equations. And we solve two-step equations using the inverse operations. So let's talk a little bit about what that means. Some of you remember that inverse operation is the way that you undo a given operation. So for example, if I had something and I was going to add a number to it, the inverse of that would be to subtract a number back away from it. If you were multiplying a number, the inverse of it is going to be division. And these could go the other way as well. If I had a subtraction problem and I wanted to do the opposite of it, or the inverse of it, I would use addition. If I had a division problem, the inverse of it is multiplication. Sometimes we might also have a problem like where we're multiplying by a fraction. And the inverse of multiplying by a fraction would be multiplying by its reciprocal. It's another place that the word inverse gets used a lot. So inverse is another way to say we're going to work backwards through the steps of solving an equation. And so it's helpful to remember that since we're working backwards, we're going to follow the order of operations backwards as well. So the order of operations is usually G for grouping symbols, E for exponents, multiplication and division, and addition and subtraction. Sometimes we just call that GEMDAS. But since we're working backwards through the order of operations, we're going to do that whole string in reverse order. So by following the acronym SAD-MEG, we can keep our steps in order for solving problems. In this video, I've got 3 example problems, and I'm going to work through each of the examples. If there's one of these that looks particularly of interest, feel free to fast forward and check it out specifically. So first, let's take a look at number 1. And thinking about my order of operations, going backwards, I'm going to check and see. I'm going to always start by looking at the side of the equation that has the variable. So here I only have a variable on one side, so I'm going to start by trying to undo all of the numbers on this side, or do the inverse operations of any number that's on this side. So here, this -9 is multiplying the n, and then that product will be added by 7. So working backwards, I'm going to undo the addition first, and then I'll undo the multiplication. So the inverse operation of addition is subtraction. So underneath the 7, I'm going to use the inverse, which is instead of adding 7, I'm going to subtract 7. And on the other side of the equal sign, I'm also going to subtract 7. So I'm just going to bring down my result. So -92 minus 7 is -99. I bring down my equal sign. And over here I have +7 plus -7, which is going to cancel out to 0. So the only thing left to bring down over here is -9n. Now this -9 is multiplying this n. So the inverse operation of multiplying is division. And I write division using a fraction bar. So I'm going to divide -9n by the number multiplying the n, which is -9. And since I divided on this side, I'm also going to divide this side by -9. I'm going to bring down my solution. So -99 divided by -9 is +11 equals -9 divided by -9 cancels out. So the only thing left on that side is the n. So 11 equals n. And I can always check my solutions by plugging it back into the original problem. So is -92 equal to -9 times 11 plus 7? Well, that would be -99 plus 7, and that would be equal to -92. So yes, indeed, they are correct. Taking a look at this next problem, I've got here 15 equals 9 plus n divided by 3. So thinking about what's happening to the n, it's being divided by 3, and then it's being added, a positive 9 is being added to it. When I have a number here like a 9, it's important to always look at the sign that's in front of it. And since there's no sign here in front of it, it's a positive 9. So I'm going to undo positive 9, which will be negative 9, or subtracting 9. And whatever I do on one side of that equal sign, I also have to do on this other side. So now I bring it down. 15 minus 9, that's 6, bringing my equal sign over. Positive 9 and negative 9 cancel out. Undone that problem. So now I bring down n over 3, or n divided by 3. So now I need to undo dividing, and the inverse of division will be multiplication. So I'm going to multiply this side by 3. Because this looks like a fraction, I like to write the multiplication in a fraction form as well, just to make it a little bit easier to see. So this was being divided by 3, so I'm multiplying by 3, which I'm just going to write as 3 over 1. Because I multiplied this side of the equation by 3, I have to also multiply this side of the equation by 3. So now I get 3 times 6, which is 18, which is equal to, got a 3 in the numerator and a 3 in the denominator, so the 3's cancel out, and I'm left with n. I'm going to check that by plugging it back in. Is 15 equal to 9 plus 18 over 3? Well, is that equal to 9 plus 6? That looks like it's equal to 15 to me. One last example here. Let's take a look at this problem. So here I've got an x, a value of x, that's being added to 9. And then this whole quantity up here is being divided by negative 11 to give me negative 2. So remember again that this fraction bar is a grouping symbol, right? They could be parentheses, they could be fraction bars. So this grouping symbol is the last thing, going backwards, right? Remember, we're doing this in backwards order, so actually we're interested in thinking about sad Meg. So the grouping symbols are going to be the last thing that we're going to undo. So multiplication and division, which is what this negative 11 is doing, that comes before we can get to the grouping symbol. So if I look on this side's being divided by negative 11. So to undo dividing by negative 11, I'm going to multiply by negative 11. Because this side of the equation looks like a fraction, I'm just going to write it as negative 11 over 1. Whatever I do to one side of the equation, I have to write on the other side as well. So I'm going to multiply that by negative 11. Then I'm going to take a look here. So I've got a negative 11 in the numerator and a negative 11 in the denominator. So those negative 11s cancel out, and I'm left with 9 plus x, which equals to negative 2 times negative 11, so positive 22. So now I look at the x, and the x is being added to 9. So I'm going to undo this positive 9 by subtracting 9. Whatever I do on one side, I also do on the other side. So x is equal to 22 minus 9, or 13. I'm going to check my solution. Is 9 plus 13 divided by negative 11 equal to negative 2? Well, 9 plus 13 is 22 divided by 11, which is equal to negative 2. 2 is equal to negative 2. So please just remember when you're solving two-step equations that you want to use inverse operations on both sides of the equation, and let Sad Meg guide you through all the problems. I hope that helps. Thanks.